This is our last example problem that we're going to be having. We have a 20-gram ball, so I did have to convert that into kilograms. Here is the radius, that's 0.5 meters. Force is 0.75 newtons. What is the acceleration? What is the velocity? And what is the period going to be? So, how could we do this? What should we do? Okay, so we have our equations that we can use. The fact that we have force, remember there's really only one set of equations that will deal with that, some type of F equals ma or a version of that, right? So F equals ma. Okay. Right, solving for A. Okay, I'm going to have acceleration, and that's the centripetal acceleration, is equal to F over m. So that's just going to be 0.75 newtons divided by 0.02 kilograms. It's a small numerator, but even a much smaller denominator. So it's going to be a larger number than you might have expected. What is the acceleration going to be? Okay, say it again, please. 37.5 meters per second squared. Yes. Okay. And then I'm looking for my velocity. I could go back to the real fundamental versions of the equation, or I could just say, hey, I've got the centripetal acceleration, and I've got the radius. Let me just use centripetal acceleration equals v squared over r. Yeah? Does that make sense? Okay, so solving for v, I'm going to get v squared is equal to r times a centripetal. So if I take the square root of that, there I am. So I plug in the values. Okay. We said r is 0.5, and the centripetal acceleration, and that was 0.5 meters, I should say. The centripetal acceleration was 37.5 meters per second squared. Notice it'll end up being meters squared per second squared, and we take the square root, that would be meters per second. That's good. Okay, so what's half of 37.5? Okay, 18 point something, and then we take the square root of that. Okay, so V equals 4.33, and that'd be meters per second. Okay, and then finally we're looking for the T, that's the period, yeah? Okay, so what equation can we be using there? Okay, so 1 over F was volunteered. Now, I don't want you to get confused. The F in the T is equal to 1 over F equation. I always write that as a lowercase f. I'll put it up over here in red. Okay. F is equal to 1 over T, and T is equal to 1 over F. This T here is a capital T, that's period. This F here, in each of the equations, is a lowercase f. That is not force, that means frequency. We don't actually have the frequency. Okay? This force right here, or this F right there is a force. Okay? So, good idea, but that doesn't work. Okay, what can we use, though? Say again? We can use 2 pi over T, yes. Okay, and that equals what? Okay, velocity is equal to 2 pi r divided by t, yes? Okay, solving for t, I can just, well, I call it the switcheroo. That's probably not what they call it in math class, but anyhow, t is equal to 2 pi r divided by v. Okay, you just have to, it's cross multiplying and then dividing, but I just call it the switcheroo. Anyhow, so 2 times 0.5, that's the radius, that's going to just be 1. That's going to be equal, and then multiplied by pi, so pi divided by the velocity, which was 4.33 meters per second, so it's about 3 divided by about 4 1/3, not exactly, but pretty close. What do we end up getting?
0.73 seconds.
Okay, 0.73 seconds. Good. 0.73 seconds. Excellent. Okay. Let's scoot down. We have a 550 kilogram car. It's driving around the track at 60 meters per second, and here's the radius is 0.75 kilometers. Notice I did put it in meters. That is important. What is the centripetal acceleration? What's the centripetal force? And what is the reason for the centripetal force? Okay, so we have all of our information. We don't care about any of that. Okay, what do you want to solve for first? Do you want to solve for acceleration or for the force? I would like to solve for the force. Yes, okay, we can do the force first if you'd like. Okay, right, okay, so, well, force, let's get a different color. Force equals mass times acceleration. Well, if I had the acceleration, then there I'd be, right? Okay, well, fine. What else does it equal? Mass times v squared over r. Yeah? Do I have the m and the v and the r? Yes. So that's going to be 550 kilograms. Okay, times v squared, that's going to be 60 meters per second squared, divided by the r, which is 750 meters. Okay? Okay, so we're tapping into our calculators right about now. Should be a force in the thousands, I assume.
2,640.
Say again?
2,640.
2,640? Okay. 2,640 newtons. Okay. Sounds splendid to me. Okay. And if we were to solve for the acceleration, we could take this value and divide through by the mass. Or we could say acceleration is v squared over r, and just say 60 squared divided by 750. Okay, either way we'll get the same answer. What is that going to be? Okay, say it again, please. 4.8 meters per second squared, right? Okay, so 4.8 meters per second squared. Okay, and then the final question was, what is the reason? What is causing this force? Okay, so I have this image here. This force is going inwards, but maybe you can't really tell. This is supposed to be F sub question mark. Okay, as in what is the reason for that force, yeah? And here's my acceleration. I just know that they're inward. I know they're centripetal, but I don't know the actual reason it's going around. And here's the velocity. Okay, so what is the actual reason that the object is going around in the circle? In other words, if I remove this reason, it would no longer go around in the circle. All right, not string. String was the case for the first one. Okay. Other people said friction. Yes, friction is the reason here. You imagine, like we mentioned before, you're driving along, and you want to go around this curve. Okay, so you just turn left, you turn right, whatever. Okay, and you're able to go. What if it's really icy out? Well, if it's really icy, then you're not going to be able to make that curve very well. Okay, reduce the coefficient of friction. That means you're reducing the centripetal force. We'll talk next time about what we can do in those situations. What road engineers have done to help us be able to make turns while still going relatively fast. Okay, any questions on anything? Okay, here are the answers written out like this in case you'd like it that way. And then the next slide is just summarizing all those things: centripetal acceleration, centripetal force, and tangential